Good evening, everybody. We are now in the final countdown for this 51st launch of Ariane 5, which we launch tonight, Arabsat-5A for Arabsat and COMS for Korea. During the last 2 days, we understood and we corrected the anomaly which stopped the chronology last first day, and we are now ready for this launch. And moreover, we had just got the information that the weather report is green for all the launch window. So we are going now to enter into really the final countdown, and I let you watch this new launch of Arianespace with Ariane 5 ECA, Arabsat-5A and COMS. Thank you.
So that was Mr. Jean-Yves Le Gall. Welcome everyone, welcome to the live coverage of tonight's launch of Arabsat-5A and COMS from the Guiana Space Center over here in Kourou. My name is Samir Amiji and I'm your technical expert for tonight's launch. And there on the screen you can see Ariane on the pad in launch zone number 3, and she's now going through all the final preparations and steps just before the launch. So we have tonight 2 prestigious passengers on board, tucked away under the fairing, which is on the top of the launcher. It's Arabsat-5A for Arabsat, who are based in Riyadh in Saudi Arabia, and COMS multi-mission satellite for the Korea Aerospace Research Institute, KARI. So welcome to everyone who is watching, our friends at Arabsat and KARI, and of course our friends at Thales and Astrium who build the satellites. So all eyes now are on the screen, the status panel, just before the launch. It's a bit like a dashboard in the car. These are indicators giving the good health of all the major systems. They give the status of the weather, which is green tonight, the spacecraft, the ground stations. And for the launch, they must all be green. So as you can see right now, they are all green, and we are ready to go. And now, this is mission control known as Jupiter Control Room. It's about 15 kilometers from the pad. And inside mission control, you have a special group of people known as the Flight Directorate. And the head of this Flight Directorate is Mr. Jean-Yves Le Gall, who is our chairman and CEO. And this group of people, they are the highest authority over here at Arianespace. And in fact, they are going to take all the important and big decisions about the launcher. So here's Mr. Edouard Perez, our Technical Center Director, that you can see right now on the screen, and Mr. Michel Aymar, Director of the Launchers at CNES. So teams have been working really hard here in Kourou for some weeks now to get the vehicle and satellites ready for today's launch. So this is why we are going to see in a few minutes a little résumé de campagne, which is a movie which is going to see what have been happening over here in this campaign.
The launcher arrives in Kourou in sections. Once they've been unloaded, they're taken to the integration building to be assembled. The solid rocket boosters, which are loaded with propellant, are also integrated here. The vehicle is then carefully transferred to the final assembly building, where teams start integrating the upper elements. It's an important phase in both the launch and satellite campaigns, and it's all about teamwork.
Above all, this is a big operational job for the teams involved. This is effectively the moment when Arianespace takes full charge of procedures until the launch, starting with the combined operations to prepare the vehicle and the payloads.
In parallel to preparations on the launch vehicle, the satellites arrive at the airport in Cayenne. From there, they're transferred to their dedicated preparation building here at the Guiana Space Center. The facilities offer state-of-the-art cleanroom technology, and the spacecraft undergo a series of special tests before being mated on top of the launch vehicle.
Le chef de mission assure l'interface et la liaison entre différents intervenants de la campagne, comme le lanceur,
The mission director
la base
acts
de
as the
lancement
link between
et
the
le
various
client.
elements of the campaign,
Pour
such as the vehicle
coordonner les
itself, the base
activités
and the
de
clients,
préparation de la
coordinating
campagne et
preparations
s'assurer
and
de la
making sure that the
disponibilité des
payloads
charges
are all
utiles
set for launch.
pour le rendez-vous avec le lanceur qui doit être le J0.
Once Ariane is complete with her passengers on board, the whole thing, including the launch table and electrical systems, is rolled out to the launch pad on special rails. It travels very slowly at 4 kilometres an hour to make sure that everything is safe. This was yesterday. It took around 40 minutes. The green light is given for the rollout only if the weather conditions are favourable.
So the whole base here is known as the range. That includes all the ground stations, which are dotted across the globe and which are going to track the launcher as it is going to fly over during all its phase. So mission control is a bit like the nerve center of the range, and all this information has to be coordinated, and that's the job of mission control. So it's a little bit like a control tower at the airport. And in that case, we could say that the airplane would be the launcher and the passengers inside the launcher would be the satellites. And when all the conditions are going to be correct, the control tower is going to give the green light for takeoff. So you can see on your screen the mission director, which is Ignacio Gori, and is responsible for coordinating the launch pad's daily activities from the arrival of the spacecraft at the base until all the activities have been completed after the launch. There is now the range operation manager, who is the head of the control tower.
VO, attention pour la séquence finale lanceur.
You just heard his voice right now, and he's going to make all the key announcements during the flight.
H0 moins 7 minutes.
And he says à tous de DDO, listen up for the range operation manager. So we have entered in the key milestone in the launch. It's the last 7 minutes before the liftoff. Computers are going to run all the final operations before the launch, and during these 7 minutes, the launcher is going to become more and more automated. So we can say now that the computers are going to take over from people. So our two passengers, Arabsat-5A and COMS, are hidden on the fairing at the top of the launcher, and they are comfortably sitting in first class with their seatbelts on, and everything is very carefully controlled inside the fairing. It's very clean. Add to this, you have air conditioning, so we can say that our two spacecraft are very comfy. And if we put now our X-ray glasses, this is what we would see under the fairing. We can see now the configuration of the spacecraft, Arabsat-5A on the top, designed by Thales for the customer Arabsat, and with a mass of 4 tons, 939 kilograms. And at the bottom of the fairing, we have inside the black box, you can see the Silda. You have COMS, multi-mission designed spacecraft, and with a mass of 2 tons and 460 kilograms. So just to remind you, we are on the equator, on the edge of the Amazon rainforest, so it's a bit hot and humid. And we just have the final weather check, and as you could see, everything was green. So we are at the end of the raining season. It's a bit cloudy and rainy over here, but it was a bit sunny today. So the rain is not really a problem. It can't stop a launch. We have other stuff that we have to monitor, like the strength and directions of the high altitude winds, but also the convective clouds and the thunderstorms in order to avoid any risk from lightning. So let's take now a closer look at our launch vehicle. Ariane 5 is a big, strong, reliable beast of a workhouse, and she's divided into 3 main stages or sections. You can see now on the screen the boosters which are appearing, the 2 solid rocket boosters with a height of 31.6 meters. And attached to those boosters, you have the main stage, the main cryogenic stage, the EPC, with a height of 8-meter building. And at the top of the main stage, you have another cryogenic stage, which is the ACA. And at the top of all that, you have the fairing with a height of 17 meters and a mass of 2.6 tons. And there she is on the pad. We have 3 launch zones here in Kourou. This is launch zone number 3. And of course, with Soyuz and Vega, we have 2 more launch zones. So the launch zones consist of the launch pad, in which Ariane is standing, the bill also, which is the integration building, the bath, where we are going to assemble the upper part, I mean by upper part, the spacecrafts, the fairing, and the Silda, and also the CDL3, which is known as the launch control. So if mission control is like the control tower, 15 kilometers from the pad, launch control, CDL3, is a little bit like the cockpit. And it's also known as the bunker. Here it is on your screen, the CDL3. And inside there are 2 teams working together. One is headed by the launch site operation manager, the COEL, which is Daniel Groult, appearing on your screen right now, and is like the pilot. And he's going to ask mission control for permission to take off. And then, when permission is given, he launches the automated sequence. And the second team is headed by the CPAP. Over here, it's Mr. Pierre-Yves Tissier. He's the Ariane production manager. And his team is going to guarantee the flight readiness of the vehicle and supervise all the operations of the launcher. So at the top of the launch vehicle, you can see in yellow those cryo arms, which are coming out from the tower and which are attaching the launcher. And they're going to feed cryotechnic fuel. They're going to feed the upper stage with cryotechnic fuel, with liquid hydrogen and liquid oxygen. So they are extremely low temperatures. To give you an example, hydrogen is about minus 240 degrees Celsius and oxygen is about minus 160 degrees Celsius. So it's really cold and we need to fill the tanks until last possible moment. And that's because the fluids are so cold and otherwise they would evaporate. And you will see those arms I was talking to you just before, those yellow arms which are going to be disconnected from the launcher 6 seconds before the launch. Another thing to look out just before the launch is that you will see 7 seconds between the ignition of the Vulcan engine and the liftoff, because the computers are going to make a check for 7 seconds to be sure everything is working properly. And after that, we are going to light the boosters, and then the launcher is going to take off. So at that time, when the boosters
attention pour H0 moins 1 minute.
When the booster is going to take off, there's nothing we can do to hold it back. So we are 1 minute before the launch.
Top moins 1 minute.
Switching to onboard power. So we are here we are live at the Guyana Space Center for the launch of an Ariane 5 ECA. We are orbiting 2 passengers today, Arabsat-5A and COMS. Welcome, if you are just joining us. Our best very wishes to Arabsat and Korea Aerospace Research Institute, and of course to everybody who has worked so hard to bring us to today's launch. So for now, let's sit back and watch.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage des étages d'accélération à poudre et décollage.
And here it is, hauling itself, again, gravity of Earth, nearly 780 tons, the equivalent of 2 jumbo jets. So after initial 6-second vertical climb and after rotation to the east, Ariane is heading out over Atlantic Ocean. So she's burning its 3 engines, 2 on boosters plus the 1 on the main stage. Actually, boosters are doing all the work over here, and their job is to get us away from the Earth. So they need a lot of firepower to push us against gravity, and they're providing 90% of the thrust right now. So they are going to work about 2 minutes, and each booster is going to burn about 2 tons of propellant a second, which is a lot, but this will allow Ariane to quit the atmosphere as fast as possible. So all eyes now are on the screen because you can see the trajectory. Ariane 5 is sending signals to the ground station to tell us about its status. So this screen is showing us those important parameters. The curve is representing the computed simulation of the trajectory, and the white spot on the curve, it's the actual position on the launch vehicle. And there are 2 other important things that you should keep your eye on. There's the V, representing the velocity or speed, but also the A, which is the altitude. And just right now, you can see that you are about 69 kilometers above the Earth, and you have a speed of 2 kilometers per second. They have now burnt all their propellant. We do not need them anymore, and we are losing weight. So actually, we have lost about 2/3 of our weight. And of course, the lighter we are and the faster we go. So the fairing that we were talking just before is at the very top of the vehicle. It's protecting the satellites from the rigors of the launch, because you have at liftoff those huge acoustic levels which are extremely loud. But we also have flux or friction, because Ariane is flying through the atmosphere, which is very dense. And generally, once the boosters are jettisoned, 50 seconds later, you have the separation of the fairing, and here it is. You can see those beautiful images on your screen. So now Captain has switched off the seatbelt signs. We are technically in space. There's no more friction. It took us only 3 minutes to get into space, and we are burning right now the main stage. The core stage, which is going to burn for 9 minutes, and it's powered by the Vulcan engine, which is extremely powerful, and like the upper stage, is a cryotechnic stage, which is burning about 322 kilograms a second of liquid hydrogen and liquid oxygen. So the job of the second stage is to put the upper stage into what we call an intermediate orbit. So to give you some other facts about the Vulcan engine, we can say that this motor was built in Vernon, in Normandy, which is in France. So we are now heading out across the Atlantic. We continue our long journey. And here is Kourou, just north of the equator. And the flight path takes us virtually along the equator. We are climbing in altitude all the time. And you know, it's a really good position to launch from, to be near the equator. So today is the 2nd launch this year for Ariane, and it's also the 51st launch for Ariane 5. And there's no question that the last few months have been really busy for the men and women at Arianespace. So let's catch up now with the latest news.
Paramètres bord sont normaux, il reste moins de 4 minutes.
For its first launch of the year, Arianespace orbited 2 satellites, A3B and COMS-BW2 on the 21st of May. Ariane 5 scored a half century, as this was her 50th flight and the 36th consecutive success for Arianespace.
At the Berlin Air Show, Arianespace highlighted Germany's involvement in the Ariane launcher family's decades of success, underlining the importance of Germany's industry and space agencies in contributing to Ariane becoming the benchmark for the commercial spacelift sector.
In June, Arianespace was a key presence at Asia's international trade show in Singapore, Communica Asia, welcoming telecommunications professionals from all over the world.
Having served the same market.
The CIO, Jean-Yves Le Gall, underlined the importance of space transportation for the communications industry. Arianespace signed a contract with Lockheed Martin Commercial Space Systems to launch the Vietnamese satellite Vinasat-2. It will launch from the Guyana Space Center in 2012, either on Ariane or Soyuz.
2010 is Franco-Russian year, and the Prime Ministers Vladimir Putin and François Fillon held a joint press conference at the Grand Palais to highlight cooperation between the two countries. Meanwhile, the French and Russian presidents were in St. Petersburg, where they watched the head of the Russian Space Agency joining Jean-Yves Le Gall in signing an agreement to allow up to 10 more Soyuz launches from the Guyana Space Center. And the latest from CSG, construction of the Soyuz facilities is going well, and the first Soyuz vehicle is already assembled.
You can see behind me, we are building the filament winding case on the PET motor, which would be used on the first stage of the launcher. It's the biggest motor of the world to be made out of one piece of composite material. And to achieve this, we have employed new technologies and we have used lighter and more efficient materials.
So the Arianespace family is moving closer to being complete there, and we are tracking the launcher from ground stations which are dotted along the equator. They have dishes like big ears, and they are listening out for the launcher as she flies over. So we have, as I was saying you, telemetry ground stations. Basically, we have 5 ground stations which are tracking the launcher. And during the flight, Ariane is going to send technical data to those ground stations, like the speed, the altitude. So we use this data to analyze how the flight is progressing. And that's my job, actually. During the launch, I'm based at the ground stations at Galileo, which is here in Kourou. So we can then analyze the information with regard to the predictions that we have made. And sometimes during the flight, we have some telemetry gap, but we have onboard memory, which is going to record the information and transmit it when the launcher is going to be visible again. So at the end of the flight, we analyze all the data and to find out how the vehicle performed. I was saying to you that there are 5 ground stations. There's one along the equator, and they are along the equator. So we have Galileo in Kourou. We have Natal, which is based in Brazil. We have also a station in the middle of the Atlantic, and it's the Ascension Islands, and on the west coast of Africa in Gabon. And the last one is in Kenya, in the east coast of Africa. So you just heard that we switched off the main stage, and now we continue our travel. Remember, at Liftoff, we started with 780 tons of mass, and now we just have 27 tons left. So the lighter we are, the faster we go, and the higher we reach. So now we are continuing our travel with the upper stage, and that's the aim of this part of the flight. Its job is to transport the satellites to the injection point and to release them into space. So, but first we have to get to the injection point. We have to reach the correct speed and velocity. So far, we have been using all our power to get away from the Earth, and now we are using it to go faster. So now we have about 60% of the required velocity, and we'll get the remaining 40% during this stage. So basically, the upper composite, it's formed with the satellites and the upper stage, which is a good, reliable engine. Like the main stage, it burns cryotechnic propellants, and every second it's going to burn about 15 kilograms of hydrogen and oxygen. So basically the upper stage is pretty much like a very small studio apartment, 4.7 meter high and 5.4 meter wide. and its total mass is about 17 tons. And most of this mass is made by the propellant. But for now,
once the satellites arrived at Rochambeau Airport in French Guiana, they were transported to the assembly buildings at the Spaceport. Here all the teams worked closely together to prepare the spacecraft for today's launch. The program director is the link between Arianespace and our customer. And for Arabsat-5A, it is Michael Calari.
This campaign had a unique feeling because there were many players involved. Arianespace worked directly with Astrium, Thales Alenia Space, and Arabsat during the integration activities. And at the start of the campaign, Kines CSG joined the team. The overall interaction between all the parties was a major reason for the success of the campaign, and the close teamwork allowed for the successful mission.
Arabsat-5A is the first of the new generation of Arabsats. It's an important spacecraft for a region which is growing in demand for new services all the time.
This successful launch of Arabsat-5A will improve Arabsat capability of providing services to all Arab countries. Second, Arabsat can operate the satellite in multi-orbital position, 20 degree and 30.5 degree, and we will enhance all the services to the Arab world. Arabsat-5A is designed for multi-mission operation, as mentioned. Mainly, it will enhance all telecommunication activities within the Arab world. In addition, it will add Asia and Africa. We will be the first service provider in the country, in the MENA area, and we will provide all the services which could be requested by the administration. One major factor now, we have separated and all we have actually made the 3 spot beams in that satellite, which will enhance the power requirement in each part of the Arab world. I can assure you that there is no competitor in the MENA area could provide the same power and the same capacity which Arabsat is providing with 5A.
So Arianespace is proud to continue supporting Arabsat in its ambitious development plan with some more upcoming launches. We are going to launch Arabsat-5C and Battle-7, by the way, and we are very pleased about that, and it will be good to work with our friends at Arabsat again. So Arabsat-5A was built by Thales and Astrium within the scope of a turnkey contract with Arabsat. And Thales supplied the payload, Astrium provided the Eurosat 3000 platform, and is responsible for its integration. So Arabsat-5A is the first one of, Arabsat-5A is the first one in the 5th generation of satellites for the operator. But before going further, let's find out more about today's passenger, who is going to provide telecommunication and TV in the Middle East.
5A satellite is really important for Arabsat and very critical for its mission. It is a result of a good work between all the teams involved in it, Arabsat team, Thales Alenia, EDS, Astrium, and also Ariane, in getting this satellite manufactured through the 2 years period, or over 2 years period, and finally putting it up in the launch pad and into space. I wish everybody a good luck, a good successful launch, and in-orbit testing and ready for operation. And good luck to all of us. Thank you all. Thank you.
One world, one heart. A world so different, yet so alike. Our world. The one and only world, where we're more at home. A world that Arabsat has been bringing closer together for over 30 years, making it today's largest Arab community in the sky. The world of Arabsat. Now, we're bringing it closer than ever. With Badr, the new 4th generation of Arabsat satellites. Arabsat. Our world, your world.
Today is a very special day, and everybody at Thales Arianespace is pleased to be part of it. Personally, I am delighted to share this important milestone with you, and so soon after the successful launch of Arabsat-5B. Arabsat-5A is the first satellite of the 5th generation, and we are very proud of it, because the technology is exceptional. Indeed, it's a first and a very exciting one. Arabsat-5A will play an important role across the whole Middle Eastern and African region. It will provide additional capacity in both C-band and Ku-band frequency. It means it can address a variety of markets, and it will offer sophisticated interactive services as well as HDTV. At Thales Arianespace, we are dedicated to support Arabsat in your sustainable growth by continuing to deliver technologies with outstanding performance. This has been a great campaign. Congratulations to Arabsat and Arianespace, and to the Thales Arianespace and Astrium satellite teams who have worked so hard to bring us together today. Everyone at Thales Arianespace joins me in wishing Arabsat and your customers all the very best for today's launch. Good luck, everybody. Shukran.
So we are flying over the Atlantic, heading towards the west coast of Africa, and we need higher altitude and velocity in order to place satellites on the correct orbit. So for that, we must do what we call a resource, pretty much like a roller coaster. Our altitude is going to decrease, but our speed will keep on increasing. So this slight decrease in altitudes will help us to go faster and higher, and will push us to the injection point, where we need a speed of about 9.4 kilometers per second and an altitude of 620 kilometers. So we have right now a speed of 8.3 kilometers per second and an altitude of about 190 kilometers. So before going further, let's find out more about carry, and that's the other topic.
Acquisition de la télémesure par la station de Libreville au Gabon.
Arianespace has always supported countries who are in the early phases of developing their programs and wish to gain access to space, and this has certainly been the case with South Korea, a country which is building its capabilities in this field.
Korea has long-term plan for space development, and following this plan, Korea has technical capability to develop low Earth orbit satellite now, and next step is to go into geostationary satellite development. KARI has jointly developed this COMS satellite with EADS Astrium. The successful launch of this COMS satellite means that we fulfill our plan, and we get the technical capability to develop the geostationary satellite.
The partnership between Arianespace and South Korea started with the scientific microsats KitSat-A and B for the Satellite Technology Research Center, and continued with the launch of KoreaSat-3 for the operator Korea Telecom. Arianespace is delighted to be collaborating with South Korea once again on COMS.
The Asian-Pacific region is very important to Arianespace. We have launched close to 60 spacecraft from this area and plan to launch 9 more in the coming years.
So during that film, we had the Libreville acquisition, which is in Gabon, in the west coast of Africa, and we have crossed the Atlantic Ocean in only 20 minutes. So that's quite amazing. It took us only 20 minutes to cross all the ocean. Incidentally, Arianespace is also going to be launching KoreaSat-6, which is a great news, and we are very pleased about that. Contracts have just been signed, and everyone over here at Arianespace is delighted that we continue this excellent work with Korea. So COMS stands for Communication, Ocean and Meteorological Satellites, has 3 different payloads, and the prime contractor was Astrium. They will come using a Eurostar 3000 platform, and the experimental payload was supplied by KARI. But for now, let's find out about that KARI.
One of the main utilization of this satellite is obviously the monitoring of the environment from this geostationary orbit. This observation, thanks to this orbit, can be made on a permanent basis, and especially for the meteorological imager, it allows observing fast evolving situations, such as the yellow sand during the springtime in Korea, and other phenomena such as typhoons. Observation of the ocean color from this orbit allows also the monitoring of very short-term phenomena such as tide effects, which has never been done from any other similar satellite from a low Earth orbit.
In order to perform optical images of the Earth, we have to perform a very accurate pointing of the line of sight of the optical instruments. So this is done thanks to a specific platform embedding a specific attitude and orbit control systems with a fiber optic gyro which has been developed by Ascent. We have embedded in this satellite a cab and payload which has been developed by A3, the Korean Research Institute on Telecommunications.
This satellite has been designed in Toulouse with the support of a Korean team of about 30 engineers who has spent 2 years in Toulouse. After 2 years, all the components and parts of the satellite have been shipped to carry in Daejeon, South Korea. This has been a real challenge, but first to work together outside of Astrium and also to work in a multicultural environment. But at the end, the result is just behind me. This is a satellite that is now fully completed and ready for launch.
With this satellite, Asrom is confirming his role of key player and world leader for export satellite on Earth observation.
So as you may know, the launcher is fully automated. That's because of the web, the VEB, which is the intelligent part of the launcher. And that's the reason it knows where it's going and what it's doing. So the upper stage has a brain. As I told you, we call it vehicle equipment B. And it's a bit just like an airplane. It contains all the avionics of the launcher. Means that the vehicle can fly on its own. And of course, as you might have noticed, it's like an automatic pilot, but there's no human pilot on board. So the web is the pilot, it's the automatic pilot. It's going to centralize and analyze all the data coming from the mission. So there's a real dialogue, in fact, between the launcher and all its parts. And the web is at the top of the upper stage. And inside the web, inside the VEB, you have the OBC, which is the onboard computer. And you also have the SRI, which are all the measurements, initial measurements that are going to say where the launcher is. And you just heard that the last stage have been switched. So for now, we are entering what we call the ballistic phase, and there's no propulsion anymore. We have switched off the engine, and we are now traveling under our own steam. And we are traveling so fast that we do not need propulsion, as I was saying. So in order to get to the injection points, we are now orienting ourselves to inject the 2 spacecrafts. From there, they are going to continue their climb and to get to the final altitude, which is about 36,000 kilometers above the Earth. And we have now to position them for the journey. So we are going to go through a carefully planned process with lots of kind of maneuvers. So the composite is getting ready now to inject the satellites into their final positions. It's a very precise process. At the beginning, we'll have the separation of Arabsat-5A. Then, after this separation, we are going to enter in lots of maneuvers and orientations in order to place the Silda in the required orientation and separate him. And once the Silda, the black box you can see on the screen, this black device is going to be separated from the upper stage, we are going to get to other kind of orientations in order to separate the last spacecraft, which is COMS. So we are orbiting 2 satellites tonight, and this is one of the great advantages of Ariane 5 ECA. She's capable, in fact, of launching 2 payloads onto GTO at the same time. In recent years, around 2/3 of Ariane missions have been dual launches. And this is because of the Silda, and here it is. The first spacecraft, Arabsat-5A, has been separated. It's a new baby is born, in fact. Here you can see Arabsat on its journey. So congratulations to Arabsat and everyone, of course, at Thales, Arianespace, and Astrium. Arabsat is an important satellite for the Middle Eastern and African regions. It will mean people can access now to some great multimedia services as well as HD TV. And it's the first one in the next 5th generation. So Arabsat is now going to go through a complex set of maneuvers as it starts its journey. And let's find out what's going to happen for next.
Well, Riyadh station is going to pick up the satellite within a few minutes from now, and we are expecting all will be okay as determined and according to the schedule. The Riyadh station will pick up the satellite maybe within a few minutes from now, and the partial deployment of the solar panel will start immediately. And this is an amazing moment for me, and I was having 2 stress at this moment. First of all, my daughter were hospitalized today, unfortunately, and she was discharged. Just I have been informed she was discharged safely. Alhamdulillah, as-salame. I love you, my family, all of you, Razan, Miran, everybody. And the second stress, Ariane is successful. This gives us a full relief that our fleet will be in safe hands, and the professionalism which I have seen during this work is amazing, really. I would like to thank Arianespace, I would like to thank Astrium, and I would like to thank Thales, which they all jointly make this event successful.
So congratulations once again to Arabsat, but we still have COMS, which is attached to the upper stage, and we'll have now to go through more maneuvers to get COMS into the right positions for separation. So the launcher has an automatic pilot, which is called a SCAR, during this ballistic phase without propulsion, is going to be the master. And this is how it is going to position itself, and this is how the launcher knows how to move around. So if we enter into more details about the SCAR, on the external skin of the launcher, you have 4 blocks of 12 thrusters. Those thrusters use hydrogen gas from the hydrogen tank of the upper stage. That's how they open and close, and that's going to give the thrust to the launcher in different directions. And this is how, with those different directions, that the upper stage is going to move around. So thanks to these thrusters, any movement is going to be possible around yaw axis, pitch axis, and roll axis. And so we can say with those maneuvers that basically it can perform any attitude.
Du système de lancement double Ariane.
But of course, as you might have noticed, all this is programmed in advance, and all this information is in the onboard computer. So you just have the Silda, which have just been separated, this black box. So a pyrotechnic device separates the Silda from its base, in fact, and the base stays attached to the upper stage. And add to this separation, we have some springs inside the Silda, which are going to increase the speed between the 2 bodies, which have just been separated. And this is going to avoid any collisions. So we have different kind of SILDA. We have 7 versions, depending on the size of the spacecrafts. So today we have a long one. It's not the biggest one, but it's about 1.5 meters higher than the standard one. So you can see now on the screen these beautiful images. But for now, let's have subjects about COMS.
After separation of the launcher, our COMS satellite will be managed by Astrium, the operation center in Toulouse. CARI engineer will join that activities. They will manage our satellite to orbit raising and deploy the solar array and the reflector. And then our CARI ground station in Korea will take care over the COMS operation activities. After that, we will perform the in-orbit test of the 3 different payloads.
So what's happening now with COMS? They now want to be separated. So they have required a low spin around their longitudinal axis. So the pilot is going to place the COMS spacecraft in the correct orbit with the required attitude. And once this is going to be done, the spacecraft is going to be separated from its adapter by the help of springs, once again, in order to increase the speed between the 2 bodies. So you can have a look on the screen and you can see that we are going really, really fast. We have a speed of 8.3 kilometers per second, and here it is, the COMS, a new baby is born. So we have now 2 new babies, and COMS have just been separated. So we continue our journey. Middle East now and South Korea have 2 new satellites. You can see all those happy faces here in Jupiter 2. I can see them from my commentary box. So everyone is really delighted with those 2 separations. Mission accomplished. But Ariane's job's not over. The upper stage still in orbit, and we have to distance all the stage between them. So what is going to happen next is that we are going to passivate the upper stage. We are going to extract all the propellants which still remains inside. And here's a replay.
Allumage des étages d'accélération à poudre et décollage.
So you can see on the screen those beautiful images of Ariane 5 being extracted from the ground and burning 2 tons a second of propellant on each booster.
Comme vous venez de le voir, ce 51e lancement d'Ariane 5 vient de placer sur leur orbite de transfert géostationnaire Arabsat-5A et COMS, et naturellement, je m'en réjouis. Donc je veux...
So you just witnessed the 51st launch of Ariane 5 that lofted into geostationary orbit Arabsat-5A and COMS. And I'm happy to share this moment with you. So, first of all, I would like to thank both of our customers. This launch was performed with a delay and after several attempts.
Je donc vous remercier pour la confiance que vous nous avez toujours témoignée.
Nevertheless, it's a perfect launch, and since it's the 37th success in a row for our Ariane, it shows clearly that our quality policy is exactly what you expect from us. And I would like to thank you for the confidence you always entrusted in us.
Et toute sa délégation pour être venue ici en Guyane assister à ce lancement, et bien sûr Astrium et Thales Arianespace qui ont construit ce satellite. Pour COMS, ce lancement
So for Arabsat-5A, this is the 7th Arabsat payload launched by Arianespace, and we are very proud of this true partnership. We have built Arabsat for more than 25 years now, and I would like to thank in particular my friend Mr. Khalid Balkiour and all his group for coming here in French Guiana to share this launch, and of course would like to thank Astrium also and Thales Arianespace who built these satellites. So the launch of COMS was performed within a fruitful cooperation with Korea, especially its space agency Kerry and Arianespace. It started with the launch of microsats, went on with the launch of KoreaSat-3, and continues today with the launch of COMS.
281 satellites, les deux derniers à l'instant. Cela va continuer.
Thank you, Mr. Minister, for coming to this launch. Thank you, Dr. Liu Li, for the confidence Kerry entrusted in our company. And since the creation of Arianespace 30 years ago, we have launched successfully 281 satellites. And this will continue since after tonight's launch, we have backlog of 34 satellites to launch to GTO, 6 ATV launches and 17 Soyuz launches. Since the beginning of 2010, we have already signed 9 new contracts, the latest one with the Argentine operator Arabsat.
Le CNES et tous nos partenaires industriels, bien sûr les équipes d'Arianespace qui viennent de réaliser un lancement parfait.
I wish to thank everyone who, day after day, take part in this success.
Nos collaborateurs sont un peu fatigués.
The European Space Agency and all its member states, the CNES and all our industrial partners.
Particulièrement satisfait de ce lancement. Et sans plus tarder, je passe la parole à nos clients pour Arabsat-5A, M. Khaled Balkiour.
But without much ado, I would like to leave the floor to our customers for Arabsat-5A, Mr. Khalid Balkiour, and for COMS, Mr. Young-Shi Kim, Minister of Science and Technology.
Bismillah wa salatu wassalamu ala Rasulillah. This has been an opening statement in Arabic, but it's been a hectic 3 days, very disturbing. We've been waiting for this launch for quite some time. Space technology is complex. We have to be careful with what we're doing, and I really like to thank Ariane, headed by Mr. Legal, and all his team. I'd like to thank CNES and ESA for all the technical support they have given to this mission. It's been a successful mission. We're glad that we have a successful launch, successful separation. We still have some time for our satellite to get in orbit and being tested and finalized, and finally being in operation. It's been great teamwork. I don't want to forget all the engineering done behind the scene from Ariane team, from Arabsat team, from Thales, from Astrium. They've been working in a very good program through the last 2.5 years. And finally, we have a successful launch. Thanks to all of you. Thanks to Ariane again. Quality is first. That's what I've been talking to Mr. Legal. It's been better being late than never, but we're glad we made it. And it's been 3 days again, tired, anxiety was high, but finally we got to rest. Thank you again. Thank you to all of you.
With your understanding, I would like to speak in Korean. 먼저 며칠간의 그 진통 속에 오늘 아리안 5의 발사체가 성공적으로 발사된 것을 진심으로 축하를 드립니다.
First of all, I'd like to really congratulate you all. After a long and winding process in the past 3 days, we have finally been able to successfully launch the Ariane 5.
또 방금 전에 천리안 유성이 천이 궤도에 정상적으로 진입을 하고 교신도 이뤘다는 소식을 들었습니다.
And it is my pleasure to tell you that I just received the news that our COMS satellite has successfully entered the geostationary transfer orbit and has achieved its first success in communication with the ground station.
아리안스페이스사에 다시 한번 감사를 드립니다.
And I'd like to thank Arianespace once again for their success.
오늘의 유성 발사는 그 어느 때보다도 그 의미가 큰 것 같습니다.
I believe tonight's success of launch is very special.
우리의 첨단 천리안 유성이 아랍셋-5의 유성과 함께 성공적으로 발사가 되었고 또 이번에 띄워진 두 유성은 앞으로 우리 실생활에 큰 도움이 될 것이기 때문입니다.
That is because our advanced COMS satellite had a companion tonight, the Arabsat-5A, and they've both been successfully launched. That's very great. And the second reason is that we believe both the satellites will help promote and facilitate our daily lives and the convenience in our daily lives.
그러나 아직 두 유성이 정상적으로 작동하기까지에는 많은 과정이 남아 있습니다. 잘 관리되길 기대해 봅니다.
However, we also understand there are steps left ahead to be accomplished by these two satellites before they enter into services.
오늘 발사된 천리안 유성은 앞으로 우주 기술 발전을 촉진시키는 것뿐만이 아니라 주어진 임무를 잘 수행을 해서 통신과 해양, 기상에 알찬 정보를 많이 제공해 줄 것으로 믿습니다.
I hope they're both managed well so that they enter into successful service. And I am sure that our successful launch tonight will help promote the development of space science as we go forward. And also that I hope that they complete their mission successfully. And also that our COMS satellite will bring to us the data for weather and ocean and communications.
오늘의 발사 성공은 분명 우리 모두에게 좋은 추억으로 오래 기억될 것 같습니다.
I'm sure, and I'm really delighted that tonight's success in launching will give us a long-lasting memory in our hearts.
또 오늘은 우주를 향한 우리의 꿈이 한 걸음 한 걸음 다가서고 있음을 실감해보는 그런 자리라고 생각합니다.
Tonight it has been indeed a great time for all of us. We have been able to really feel here on the on-site here that our dreams toward space for humanity is coming closer.
여러분 수고 많았습니다. 다시 한번 축하드립니다.
Thank you everyone for your hard work and congratulations once again.
Très bien. Eh bien, il me
Once again, thank you and bravo to everyone. Our next launch will be beginning of August for new Ariane 5 ECA mission with two satellites, RASCOM CAF-1R and Nilsat 201. Thank you and good night.
Nilsat 201 pour l'Égypte. Et donc, ça aura lieu le 3 août, c'est-à-dire dans un peu plus d'un mois. Voilà, une fois encore, bravo et merci. Bonsoir.
Si d'ores et déjà toutes les personnes qui ont rendu possible cette vidéo-transmission, Emmanuel Delira, le réalisateur.
So before ending this video transmission, I would like to say thank you to everyone. Also give a kind regards to Mr. Frédéric Gauthier, who has worked hard in Arianespace and who passed a couple of days ago. So I would like to transmit on the name of Arianespace best regards to all his family team. So thank you everyone once again for everyone who has worked hard on this team. It was Samir Amidji. Goodbye.
Trajectoire normale. trajectoire normale.